Hey, what's up YouTube? So here I am in my new location in this garage here, and I've put together a new circuit here. It's a white LED circuit. It is comprised of a power supply, a custom made driver that I put together, and of course this microwave white LED circuit here. So yeah, I'll show you how I put this together, how it works, and we'll do some testing and measurements to see how this thing actually operates. So for powering the circuit here, I'm reusing this 30 volt rated power supply that I salvaged from some old electronic equipment. And I have the output wires modified to a 30 volt potential, more or less. I have the positive wire going to the driver here, and the negative wire is connected to the LED here. So as for the driver, I'm using an LM317T adjustable voltage regulator. But here I'm actually using it as a current regulator for regulating the LED. And the reason that is because LEDs and even laser diodes are negative temperature coefficient. So they rely primarily on current for driving the emission states from LEDs and laser diodes. So I have the positive output wire going to the positive inputs of the semiconductor here. And the semiconductor is heat sinked here to the sink using silicone here. For load resistance, I'm using a 30k ohm resistor, which is connected from the adjustable pin to the positive output pin. And I also have a bunch of wiring for more power draw from the circuit here. And of course I have the positive output pin wire connected here to the positive output of the LED here. The fan is powered via a VTPL switching power supply rated for 6 volts at 400 milliamp output. As for the emission source, I'm reusing this white LED circuit here that I salvaged out of a broken microwave, and it still works great. I have it heat sinked here to this metal sink with a 5 volt fan strapped to the underside for cooling. The sink is just for dissipation of heat waste. And I have it bonded here using transparent silicone. I have one screw to keep the LED circuit board secure on this sink here. These microwave white LED circuits typically take a higher voltage than your typical LED or even laser diode for that matter. And that's the reason why I'm using this 30 volt rated power supply for the input. Now, although these two white LEDs here only get slightly warm during operation, if that, the bulk of the heat stress actually accumulates in the surface mount resistors here. And there's two of them, and those are what's driving the current from the driver to the LEDs. So to mitigate that heat waste, I've got acrylic aerogel, well insulated at the bottom, which is covered in a layer of transparent silicone, which is then wrapped multiple times using electrical vinyl tape. So that, alongside with the fan at the bottom, should be enough to mitigate the heat waste that accumulates on the surface mount resistors here. Alright, so now that I have everything connected, let's flip the switch and fire this thing up and see just how powerful and bright these microwave LEDs can be, at least in this configuration here. Alright, now we can fire this thing up. And as you can see, it's very bright. This single LED circuit could probably and nearly light up the entire garage in here. Here's the emission state with the lights off. Alright, now we can measure the output voltage of the white LED circuit here. And here we have an output of 22 volts. overall, this is a pretty cool and useful lighting system. It is practical for workbench related activities and just for lighting setups in general. It is somewhat efficient, has a fairly long lifespan, and is fun to operate. So anyways, thanks for watching and stay tuned for more videos.